So today we're going to be looking at using conditional probability in multiple event sort of situation. So Bruno has a 75% chance of winning any particular game of darts. Determine the probability that Bruno wins a set decided by the best of 3 games, given he wins the first game. Well, since he's won the first game, that means he's either won 1 or he has won, lost 1. Because in a best of 3, you only need to get 2 wins to win. Third game doesn't matter. So if he wins the first 2, they don't need to play the third game. He's already won the best of 3. And then win, lost, win. So let's say W is Bruno wins. L means Bruno, well, I'm calling him Brulo. Bruno loses. So that means the probability of W is just 0.75. And the probability of him losing, well, that'd be 0.25. Either he wins or he loses. No draws. So then what we want to do is we want to find out whether he wins the set. So let's say S is wins the set and F is wins the first game. Alrighty, so we want to work out the probability that he wins the set given he wins the first game. Well, that's going to be the probability he wins the set and wins the first game over the probability he wins the first game. Well, that's easy. The probability of him winning the first game is going to be just 0.75. It's the same as him just winning. The more interesting part is how do we work out S and F? And the easiest way to do it is, as usual, with a tree diagram. So in the first game, he can either win or lose. In the second game, he can either win or lose. And then in the third game, he can either win, lose, win, lose, win, lose, win, lose. In fact, the bottom option and the top option don't actually matter because you wouldn't play another game if you have already won 2 games, already lost 2 games. You wouldn't bother playing the last game. So, what's the probability? Well, we just need to work out what these 2 probabilities are from this tree. So, let's go through and work it out. The options we're interested in are the probability that he wins the set and he wins the first game. Well, there's only 2 there, which is the probability that he wins, plus the probability that he wins, loses, and then wins. Now, the probability of win-win, well, it's just going to be 0.75 times 0.75. And the probability of the win, loses, win is going to be 0.75 times 0.25 for the loss times 0.75 for the other win, which gives us a total of 0.703125. Alrighty, so we now have the 2 pieces of information we need. We've got this and we have this, and so we can substitute it into our formula, which is going to be 0.703125 over 0.75, which is equal to 0.9375. And there you can see we have now worked out the probability that he wins the set given he won the first game. Alrighty, see you in the next one. Goodbye.